We are now very much looking forward to our next speaker, Dawn Nafus, who has joined us today from Intel Labs and will need to rejoin Intel Labs at the top of the hour, so we will be very punctual. I've asked Dawn to give us some of her latest research at the cutting edge of AI development in Intel Labs, and I will introduce her and allow her to have all platforms shortly. I've known Dawn for many, many years as a collaborator and colleague, and so very much miss our collaborations, and I'm really delighted that we can do it today, virtually at least. She is, if you don't know, Senior Research Scientist at Intel, where she manages the Sociotechnical Systems team, and her current research focus is AI and climate change, with the emphasis on the changing infrastructures of computation. She is truly a pioneer in this field we've been discussing already today, which is the energy social sciences, and has done many great projects both in academic and industry forums. And prior to this work, she was editor of Quantified, Biosensing Technologies in Everyday Life with MIT Press, and co-author of Self-Tracking with MIT Press. She's also co-editor of Ethnography for a Data-Saturated World with Manchester in 2018. And I think ethnography in a data-saturated world is exactly what we're about to hear. Dawn, welcome to the ADM+S and to Electronics Ecologies. Please take the floor. We are looking forward to hearing your talk.
Thank you so much for that incredibly generous introduction, and also for putting this together. This has been just incredibly generative. If you have noticed me being very quiet, it's because I've been listening and taking notes intently and nodding furiously without any video to kind of express that. But yeah, I just wanted to thank everybody for their work, and you'll hear resonance, sort of across the different talks. So what I'm going to share with you is extremely raw, extremely. So this is really the first time I've tried to take a step back and sort of ask, okay, what the heck is going on here? And you'll also hear a lot of this kind of, this quandary that I think has been coming up, for the last hour or two, I guess it is now, about, what does it actually mean and what does it look like to make an impact? So one of the things that I'm really, frankly struggling with right now is this really kind of fundamental question of does AI, quote unquote AI, we know it's not a real thing, but never mind, we'll say it, does AI actually have a role at all to play on a livable planet? And I'm actually not settled on that question. And the stakes, I think for everybody are high. They're high for me because I'm in an AI lab, and I do responsible AI governance as part of my job. And so very much having sleepless nights over this. Right. Okay. So I'm just going to share a little bit about these are just some numbers to kind of give a sense for what we might be talking about when we talk about the climate impact of models. You'll notice that these focus on emissions. Obviously, water is a gigantic problem. Materials, right? There's a bunch of things that are not CO2e, but for reasons that will become obvious later, this tends to be what the AI world focuses on. As I was putting this together, I blatantly stole this slide from some other work that I do internally, so you can sort of see how folks talk who are inside large companies, and then realizing with whom I was speaking, I realized just how awful and ethnocentric the whole thing was, to key off of your average American as if that was some kind of baseline worth having. But there you go. That's what we have. and these numbers are sort of meant to shock folks, right? Like, oh my gosh, so many tons. It kind of also has this effect in a way of, at a certain size, a number just becomes big, right? It doesn't actually matter if it's a million or a billion. Like at a certain point, your eyes just glaze over, and it's just a lot, right? And so this is, a common rhetoric that gets used. Sometimes I use it to say a lot. If you look into the kind of the technical research, which I occasionally do for my sins, it's a lot is a little bit different. So there are lots of models, lots of work in AI that really isn't of that kind of the spectacular a lot. That there are some, for example, computer vision models that can actually get quite small. There's some models that as you can see here are just to train them and just to be very clear about what AI is, right? There's like the training part, which is when you introduce the algorithm to all the different examples of data, and it kind of learns to distinguish between a cat and a dog or whatever it is. And then there's the inference part, which is now I'm going to make a guess about, is this a cat or a dog? Or I'm going to make a guess about what the next word is that you're going to say, right? So there are really two parts of the equation, right? The numbers get very spectacular in the training part because it happens all at once. It turns out lots of folks are saying now that actually we should really be worrying also about the inference part, right, the making guesses part, because even though that's spread out over lots and lots of times and places, in aggregate, it can get double, triple, whatever it is, depending on how often these things get used, right? It ends up being more than training, unless you build a model and nobody uses it all, in which case it's all training. But this gets very serious when things start to move as they have into what's called generative AI, right? So again, making a guess about the next word or a guess about an image that you might have in mind when you put it in a website. And while getting access to actual data is really hard to come by, there's some talk of this, using kind of a large language model to do something that would be the equivalent of search, ask a question, might involve something like 10 times the amount of energy than if you just put it in, an ordinary search engine, right? So what's concerning here, and has a lot of people starting to put attention on this issue, is the overall trajectory, right? So that once kind of deep learning came to town, the amount of compute power that tends to be used, right, the amount of cycles that you need is sort of doubling faster, right? Large language models, it turns out, according to this paper here, don't double as fast as your kind of vanilla deep learning models, but they do double, and they're really freaking big, right? So they're both a problem, but they're kind of different kinds of problems. And so I started to be concerned about this. I've been concerned about this for a while. As I said earlier, I do responsible AI governance work. So, we've been asking lots of questions about actually how do we, and, assuming regulations are coming down the pike, about, sustainability and doing an impact assessment there. Lots of questions have been raised about how do we even do this, right? As Tamara and Mel know, when I think this was about maybe last year before last, I can't remember now, the way I started out methodologically was really to just have conversations with people who were building these things. And it was really just an act of breaking the silence. It was, you could call it ethnographic interviewing, but it was really a silence breaking. And what I found was that, for the most part, there were it was either the case that, this was not a topic that, the person I was talking with had thought a whole lot about, but as soon as we started talking, actually, they thought a whole lot about it and came to sort of think about ways that they could actually do something, right? There was also a group of people who were really suffering quite serious climate grief. Were deeply frustrated that this was not, being made a bigger issue of, but still, didn't quite see a path to, how to incorporate this into work. And so I then did a second round of interviewing. This time really expanded. It's all interview based, which, someone trained in participant observation is it's not the most satisfying thing in the world, but it's what I can do based on where I am. But so I set up the second study, right, to really try to understand, what's going on here. And the way I want to introduce that second study is actually through a survey. And because I think this survey, which came out last year, I think it really encapsulates the problem that I'm trying to wrestle with, or the problem that emerged in this second round of research. So I'll share with you what these results were first, and then we'll kind of backtrack and try to unravel it. So, okay. So this is a survey by and for natural language processing researchers, right? So it's a mix of, these are, very, very large, super popular conferences. Everybody's trying to get themselves into these things. It's a mix of academic computer science and industrial R&D. That is very much a revolving door, as you might not be surprised about. Right, those distinctions are really even more porous in computer science. And they took it upon them. This research team took it upon themselves to survey the field. And what was kind of shocking was that, okay, you've got just over half of researchers saying, yep, the carbon footprint of training large models should be a major concern. And of those, you can say it's super gendered, right? Which I think speaks volumes of about what's actually happening here. That almost 80% of the women agreed with this statement, much less so the guys. The other thing that's happening here is you've got 72%, right? So pretty solid majority here, saying that currently the field focuses too much on scaling up machine learning models, right? So one of a very common technique in NLP and also other fields is to take a known method, right, a known model of some kind, and the only thing you do is throw more data at it, and therefore more hardware at it. And this is also colloquially known as the brute force method. You just sort of brute force your way through, and out you have an answer. And it's just a little percentage point above like what's called the state of the art, right? So there will be a benchmark data set, right? Everybody tests their stuff against, and the game is to get just like 2 or 3 percentage points above, the last person. Right. And, people are saying that this is a problem, right? So that's the very thing that's behind those doubling rates, right? It's this constant kind of, one-upsmanship. But people are saying that this holds no value, right? They're like that the field's over focused on this, 17% agreed that there's, this solves no real world value problem whatsoever, right? All right, so we've got this remarkable kind of result in a way where people are conducting research in ways that they themselves see as largely nonsensical, as largely unscientific, and they're doing it anyway, despite the climate harms that they themselves say needs to be a major concern, right? So that's weird. And there's something going on here, right? We're all, sort of trained to figure out, okay, there's a social logic at stake. And I wanted to think about what that was, right? And we can take a couple obvious answers, right? I mean, we can take the political economy answer that says, okay, right, follow the money, and the money is where the resources are, the capital, and that translates into access to compute resources. And surprise, surprise, the entities that make money out of monopolizing large-scale resources push the field to be about large-scale resources, right? That's not a coincidence. It's obvious. In my interviews, folks told me that this is explicit, right? So as in PhD programs in computer science, folks move between academia and industry. And for folks who had done internships at the large cloud providers, this was a task that they were set. They were said, think big because we're the only ones that can do it. Right? It's very, very explicit. Right? Okay, so there's that. There's this issue of climate change always has this issue of taking a backseat, right? And folks have often thought about that in terms of, well, it's a kind of a distant thing, right? There's no immediate effects, or the effects are on other people, and all that sort of stuff. But in a sense, I just don't buy it, right? Like that the folks that I spoke with were very explicit about the effects here in the here and now that they were seeing, and it was very clear, right? Okay, so I set out to ask a new round of questions, right? This time, also including folks in academia, folks at other companies. And what I really wanted to do is to sort of unravel this kind of weirdness of why are people doing things that they themselves don't remotely believe in, and that the kind of the emptiness of it all I was sort of really taken by. But I wanted to get at that also through some pretty concrete stuff, right? So I wanted to understand what was on the table for folks who are in this world, right? What do they imagine that they can actually do and not do, right? Because there are a series of things that are more or less readily available with some doing. So, as an example, there are plenty of techniques you can use to make a model more efficient, which, as I think it was Anne who mentioned, there are all sorts of problems with efficiency, right? In terms of sustainability, but it's something that one can at least do. It's also extra work, right? Somebody actually has to go about doing that. And particularly when you're in an R&D context, it's not clear that you would, because often that's seen as somebody else's problem. Another thing you can do, again, is, which Tamara kind of alluded to, is you can move around the workload in time and place. This is called carbon awareness. I like to call it carbon responsiveness, but the world does not. And, I really pay attention to that, to the geography of where the energy actually is. But again, that also has a very concrete impact on people, right? Like, it's, if you have to wait 6 hours, for the sun to start shining, how is that actually going to happen realistically? And then if your data center is not the big magical cloud that's gigantic and seems infinite, but actually like limited, which a lot of these things are, and everybody's trying to do that at the same time because they're all trying to go off to some natural language processing workshop, right? There's sociotechnical limits, right, to how much this stuff is going to work. So I wanted to understand what those things, okay, what's more appealing, what's doable, what's on the table, and is there anything that is a rethink on the table at all? So that's what I set out to do. One of the things I learned, which actually gets back to, some of the earlier conversations we were having about, I think it was, that kind of, I think Anne called it the consumer climate guilt thing. And, what was what was fascinating, so one of the things on the table, right, that I'm putting on the table is simply having to see predictions about your emissions before you send your work off to your computing resources to do the job, right? So these are jobs that like will last 8 hours, 24 hours, sometimes multiple weeks if you're ambitious, right? So it's a kind of a send it off and then go do something else kind of a deal. And what was really interesting is this very much put people in this it's almost a subject position thing in a way, right? Because this for the folks that I spoke with put them into the kind of the consumer slot, but they were doing it at work, which was kind of like a funny thing to do. So they would say things like, the way they related to it was, oh, this is like when I get my electricity bill and I've been on a bread baking binge, or one person, bless his soul, wanted to know how many trees he had to plant in order to make up for the AI that he had just trained. And I didn't have the heart to tell him the answer because I think that's going to be a lot. Like, that's a lot of shoveling. But that's what he wanted to do, like that kind of like consumer level, like this individualizes, right? And so, these are folks who at one level, do have more agency at their disposal than, say, change the light bulb in your house, right? Or turn off the light, or like stuff like that, right? I mean, this is real stuff. So another thing that happened with surprising consistency was that I was worried that the numbers you're seeing here would look low, like that it would be kind of ammunition for a dismissal. Like, oh, it's only 2% of a small flight. Like, I'm not worried. Like, that's what I was worried about. But actually, it was the opposite. So as soon as I did show stuff like this, folks did the arithmetic pretty darn quick and realized, as this person did here, oh, it's quite shocking to see because this is only one run, but we do this all the time. We have multiple people doing this. So it was already adding up in their minds, which was good, right? So that's promising, right? So one of the things we're considering now is putting this in before training runs, just to introduce a little bit of friction, because often it turns out that what people will do is they'll set it and forget it and hope there's no bug in the code. So it could go a couple days and then just go like, and there's nothing useful there. And so this might encourage a little more debugging before letting the energy do it for you, as Zane might have elaborate commentary on. Okay. So let me see where I am here. The other thing that I said, there's also a flip side, right? So the one person I spoke with who was kind of against this, he was like, no, you should not do this, right? And this was somebody who was very serious about labor rights. And his argument was that this was effectively responsibilization, right? That what workers, right? These are workers, they're elite workers, but they're workers nonetheless. They don't always set the technical trajectory. They don't always set the business model. And so, if you're hired to do a large language model, right, that's what you're hired to do. So, so he was pointing out some limits. The way others would point out those limits is to sort of, really caution me against, look, I don't want this being used as a kind of the odious comparison, right? Because I know my colleague is hired to do the large language model. And even though my model isn't that, something quite small, it's just not a fair comparison at all, right? We're here to do those things. So that's in a way where, people started to find their limits. So yeah, so what was promising, I think, about this whole endeavor is that there was this notion of, there was a default assumption, with some caveats and limitations, but the default assumption was that there's something here in my control. And that was surprising to me, because in the work that I did over thinking about all the other topics of responsible AI, like, for example, gender bias, racial bias, privacy, surveillance, transparency, all that stuff. I did some work with a student recently about all of the clever ways that AI developers will find to tell you that responsibility is absolutely not their problem. Right. So, oh, that's like, and it really has to do with, oh, there are these mushy humans who I don't understand, and I can't predict what they're going to do, or I'll make a model and then I give it to the next company down the line, who gives it to the next company down the line, and by the time we're at the end of the line, I have no idea what's going on. So, not my problem, right? So there's like a ton of not my problem, but this was not my problem, which was, again, like, really, like, how is that? And so I have this team. I lead this team, and we're trying to work out some better ways of doing carbon aware stuff. And right now that team is trying to bottom out on how do we do power measurement, because it turns out, being able to do this stuff, you have to make an assumption about power. And to their consternation, but to not to the surprise of anybody here, they come back to me and they say, but Dawn, this power, turns out power is subjective. I can't believe it. They don't like it. It makes them uncomfortable. And the reason it makes them uncomfortable is, so it's supposed to be sixth grade physics, right? Like, it's supposed to be, they're imagining a beeline between the job and some software, some hardware, and then you pull energy from the wall. And that's the mental model. And then when they have to actually cut the network and make a decision about what that looks like, there's like chaos. Right? So this blows their minds, it blows them up. But it is also the thing that they've, like, provided you can sort of squint hard enough and just settle on any number at all, folks can generally, they see their own agency, at least in this field. Okay. So there's that. But there's still this question, right? So, as I said earlier, I'm kind of having a little tough time here figuring out, are there glimmers here, right? If I say do some craziness with, like, what's called batch sizing, or making the things more efficient, or like all the tricks you could do to not actually to make things a little bit better, but not actually question AI, right? Is there still a glimmer of that deeper rethink? Or are we, or is my job putting lipstick on a pig, which is the thing that I just can't get out of my head. So, okay. So I wanted to share two stories. And so I'm an anthropologist, so I'm just going to share two stories of two different people. And I think they're interesting glimmers into, well, maybe there's more that is possible, right? So my first story is about a guy, he's in kind of an obscure corner, machine learning. I won't tell you what it is, because it is that obscure and specific, but really just sort of a sleepy little corner. And he works for a company, works for it's called an ISV, an independent software provider. And, and he's really, like, I'd call him like customer oriented. Like, so he will bend, he bent my ear about, look, I understand that that survey result that, I didn't mention the survey result, but he was talking about, why folks might be skeptical of, all of those benchmarks, right? And he was skeptical of, and he doesn't, sorry, I should have said, he's really kind of stopped publishing. I mean, he does a little bit, but it's not really what gets him excited. What gets him excited is seeing his stuff out in the actual world. And so he's trying to do that. And he says, he's looked on, all of those accuracy numbers, right? Unless you're doing something very, very specific and very, very high stakes, it doesn't actually matter a whole lot. Like, if you're getting the job done and the thing works, the difference between 1 or 2% accuracy points, no one is going to notice. Like, it's absurd. And all those benchmarks actually don't, all that data that's in the benchmark data set doesn't correspond to the real world. So you're never going to achieve those numbers once you actually go into the real world. So, like, why? Like, why? Like, he didn't care. And so, okay, so then I did the whole thing where, I showed him that, that his emissions numbers, had put in your last workload into the emissions calculator, out of popped, and then I asked him, well, what else would we do? Like, what else would you want to see besides, the numbers you're seeing now, right? And I'll just sort of go back to this. Yeah, what else would you want to see besides these numbers? And he said, oh, well, this is nice for just one job, like just one training run, but what I want is the whole trajectory, right? Like, what I want to know is my research moving, in a more sustainable trajectory, right? So, which says a lot, right? About, oh, there is this capacity to think long term. There's another person, actually, this time a student, and then I'll stop talking. This time a student. He had been in industry for many years, making chatbots for the finance industry, and realizing that his job in life was really to routinize white collar skills and de-skill them. He goes off to do a PhD. In that PhD, he does a stint at NASA, sees a bunch of astrophysics papers. And astrophysics papers are like 2 pages long. And he gets super into this, right? And what he wants to do is he wants to write an astrophysics paper for an LP conference, for a big machine learning conference. And he's really into math and really into the elegance of math. And what he wants, and he really, he's like, this benchmarking stuff, it's like throwing spaghetti at the wall to see what sticks, right? You're not actually, like, very few authors can actually tell you why they're getting the results they are, right? So he's like, I want to write something super small that is almost like a mathematical proof. And so he did this weird thing where, he asked, okay, what is the simplest possible model I can do for this one task, right? And it achieved, like, not the benchmark, which is like just south of it, but it was remarkable that he achieved it at all, because he did it in this bizarre way. Thing gets wildly rejected, right? Like this was like a career-ending move for him. He later gets redeemed, but the point is that the reviewers really want, like, more and more experiments, right? Like, in a sense, you can see the routinization of the field itself, like, as a research endeavor, through the insistence of reviewers. And so we kind of started to joke about reviewer 2, right? And eventually I asked him, look, how many, like, if you look at your university's compute resource right now, how much of your department's compute is really the result of reviewer 2 just getting pipey and just needing placating? And he said a lot. Like, a lot. So we ended up figuring out that actually the carbon intervention here is a carbon tax on reviewer 2.